Finishing up, let's take a look at what happened here. So we're going to look at the reduction the reaction is taking place in a basic aqueous media. So we're in water, and it's going to act basic. So we're going to look for a reduction potential for H2 in the table. Reduction potential for H2 gas. See if you can find that. Go quick. Practice. Look on your table. You can find it. Anybody have that? I see it. Quarter the way down. What do you got? Zero. Okay, good. That's actually a good thing. All right, now calculate the oxidation number. So we have to look at aluminum. Aluminum by itself is going to be 0, and it's going to be minus plus 3. I don't know why it says minus 3. It should be plus 3. Sorry about that. Plus 3 on that side. To give you what happened, what are we doing with electrons when we go from right to left, left to right? 0 to plus 3. Losing them, so minus 3 electrons. Make sure it is plus 3 on your page here. It still says minus 3 on some people. It should be a plus 3. Sorry about that. I probably mishandled that. All right. Now, the other thing is this. So we added the water, and now look what I conveniently did. I popped in water on this side. Why? What happened with our hydroxides here? Both the same here. These are both the same. So obviously H2 had to come from somewhere else. It came from the water that the solution was in, so I popped it in. We're going to talk about the individual rules about when you add water or hydrogens or whatever in just a minute, but just to kind of get a starting point of where you are, I added the water, I checked the hydrogen. I had, on one side I had +1, the other side I had 0. I transfer the redox partner. So I'm going to take in order to make it a balanced equation, my 3 electrons that I had here, this 3 hydrogens, this 2 is going to come up here. Now, are we good? Are we balanced? Maybe not exactly yet. All right, mass balance. So we're going to go ahead and add our 6, our 2, and our 3, and our 2 right there. Okay? So it looks a little different. We added in the water. We got it through. We're still maintaining it in an aqueous solution. And did you kind of understand what I did with the electrons and how I kind of transferred that in there to balance it out? No, we got a no on that. We got a shaking head no on that. All right, so let's go back a little bit. Let's rewind. All right, let's rewind. All right. Does everybody see how this goes from 0 to, excuse my typo, 0 to plus 3? Everybody see that? Okay. Now, I also go from, all right, I'm not going to change this. This is exactly the same, so I'm not really including that right now in my overall thing. So you got to add water to one side or the other. Well, in order to get H2, my water needs to be added to this side. So I have +1 and I have a -2. Well, I have 2 of those. 2 times +1 gives me a +2 charge. So I have 2 times 1 electron being transferred. Now, from there, I have to do what? I got to balance this side, the right side out, in order to figure out if I need any electrons or anything further on the left side. Well, we're really not going to need it. So this 3, in order for you to get the 3 electrons that came from the left side, that were losing 3, they have to somewhere pop up on the right side. Well, these 3 electrons, this 3 is going to go right there, and then my 2 electrons is going to slide right up here. It's going to slide right up here. You have to have the transfer, they have to be going somewhere. You have to figure out where they are going. All right? So initially there, I had a +1, I had 4, and popped it right into that 0. Let's try some more. Maybe this one was a hard one to start with. Seems like that every year. This one's always hard for everybody to start with. All right. So now we have lead hydroxide, lead 3 hydroxide. We have a little oxygen chloride, little lead 4 oxide, and chloride. All right, so let's try to figure out real quick what are the reduction and oxidation pairs. See if you can do that. That would be a good start. If you want to have this kind of like this, kind of gives you a little bit of a, I don't know, a way to kind of look at it. Just have it opened up. All right, anybody figure out what the reduction pair is yet? Anybody figure out the reduction pair, the reduction pair? Yes.
It would be OCl and Cl minus.
All right, OCl and Cl minus. Why do you say that?
Because the Cl has an oxidation number of +1 to -1. OCl and what? And Cl.
I can see where you're going with that. I can see where you're going with that. What'd you say for oxidation? All right, so lead goes from 3 to a 4. All right. Anybody else have anything different for OCl and Cl minus? Anybody have anything different? Anybody have a charge of oxygen as any different? Okay, good. This is good. We're doing something that may be challenging right now to you. All right, so let's take a look. We have these two. We want to have these two half reactions. So these are the ones we're working with, which you identified to this point. So we're splitting it in half. One is one side, and we're going to add them together. So if we take a look, we're going to mass balance both equations. Add waters to balance extra hydrogens. So see if you can do that now. All right, so right on the bottom, you want to add waters to balance extra hydrogens on both. See if you can do that to both. Anybody have any idea how many waters you're going to add to the first one? Anybody know how many waters you're going to add to the lead 3 hydroxide? To the right side. Anybody, give you hints on the right side. Anybody have any idea how many other oxygens you need? Three waters? Okay, so we have 3 waters on the floor. Anybody else? Anybody else? Anything other than 3 waters? 3 waters. 3 waters. 3 waters. Anybody else for 3 waters? Did anybody agree with 3 waters? I got one person raising their hand. All right, if you don't agree with that, then I need other answers. Yes? 6. I got a 6 on the board. All right, anybody else? Spency? All right. Let's take a look. I'm going to add 1 water. Why am I going to add 1 water? Why am I going to add 1 water? Well, I have how many oxygens here?
2.
How many do I have here? This makes it 3. How many do I have here? 3. Now, it may change total after you get to the balance it, but right now I'm adding 1 water. What about the bottom? Andrew, what do you think? 1 water. 1 water. Okay. All right. We're building. We're slowly building. We're building up the train here. All right. We're building up the train. All right. Next. Then add extra hydrogens to balance extra hydrogens added from the H2O. Okay, I think we could do that. So try to do that. I think you can tell where they're going to go maybe. Left or right side, it could be on either. Anybody think they got one for the first one? First one? One on the right side. How many people agree with that? One person? Two people? Three people? Michael says yes. All right, I'm going to add a hydrogen right there. Now I'll try the next one. How many do you think you got to add for the other one? Where? Yes, yes, yes. Not that bad so far. You got to know these steps in your head though. I'm taking my time, going through those. So far we got some half reactions. Do you think we're going to have to do anything else? Electrons. All right. Charge, balance both equations by adding extra electrons to the side where you need the electrons. Well, it's probably going to be the opposite side of where you added the hydrogens, maybe. Maybe not. It might not be. You may need an extra one, I know, somewhere else. Not be. All right. Give you a second to process. Two electrons. All right. All right, Nikhil, what did you do?
I added 2 electrons to the right side.
Of the first one? Why 2?
Because on the left you charge -1, on the right it's +1.
Aha! Aha! Give yourself a little shoulder brush there. Lean back. All right. Because the left side has a -1 and the right side has a +1, how do you get the charge to be the same of -1? Add 2 electrons. Jamarco, what did you do for the next one? Give it a shot. Give it a shot. What's your total charge on the left? +1. What's your total charge on the right? So where do you think you'd add electrons? To the right or the left? It doesn't have to be opposite hydrogen. It's just the total charge balance. What's the charge on the left? Overall charge? +1. What's the overall charge on the right? They gotta be equal. They gotta be equal. There it is. There it is. Do we have all of our blanks filled in now? No, we don't. So, wait a minute. Cancel out any common terms. All right, so we can do that and do that. Is there anything else we can cancel? Yes, make it 1 hydrogen. Now, step 5. Is the reaction taking place in a basic solution? Are there any H pluses left? Add OH to both sides if there's any H pluses left. Are there any H pluses left? Once you get the little trick system down, then it's easy. It's just the first or couple times you see it, it's kind of hard. All right? What'd you do, Spency?
Added an OH negative to the right side.
All right, and OH negative to the right side. Add OH to
Both sides.
both sides. Both sides.
So on both sides.
OH there and an OH there. And guess what the OH negative plus H plus is going to give you? Water. Okay. So you add it to both sides. H and OH will make water on one side. Add the two. Wait a minute. Let me go back. Check it out. I'm going to go ahead and combine. Ready? Watch my lovely animation. It took me a while. All right. Ready? See that? Oh, you missed it. Wait a minute. Wait a minute. Okay. Let's see. Ready? Add the two half reactions and cancel out any extra water. Now what happened? What appeared there? Where did those two electrons come from? What am I going to do with those two electrons? Let's take a look. All right, so I'm going to add those up. Those were already canceled. That was just my mistake. my bad. It was, sorry, I tried. All right, so now I add them up. All the reactants and all the products, cancel out any like terms that I have, and I get to my final answer, which is going to be PbOH minus 3 plus OCl, PbO2 plus Cl plus OH plus H2O plus OH minus.
Why did it become 2H2O?
Why? Because you had two right here. You had this one. You're adding this and this. These add up. Okay? Draw a circle there so you know. Draw a circle so you're left with one water and one hydroxide. What do you think would happen if it was in a basic solution? What would be the difference? Or an acidic solution? You'd be adding hydrogens. Okay. All right. Okay, so that's a start. That's a start. Now this one, I don't think you have this slide. You have this slide? No. All right. We got that. We're good with that. We've gone over
Can you
that.
go backwards on this?
Yes. The OH. Yeah. All right. So oxidation numbers, we've done that. Okay. Balancing redox equations with the pH is acidic. Identify the atoms that are oxidized or reduced using oxidation number. Half reactions. Balance mass. Okay, highlight circle number 3, the two parts. If there's any oxygen atoms present, balance them adding water. If there are any H atoms present, balance them adding hydrogen. Balance charges with electrons. Multiply the half reactions, excuse me, so that the number of electrons lost in one equation. So we didn't do step 6 yet, so you know that's coming. All right, so highlight step 6, then add them together and cancel out. We haven't done 6 yet, so you know that's coming. Okay? All right. Oops. All right, so here we go. Now, let me do my little magic wand here. The reveal. All right. Yeah, you didn't want me to just plop this on you like a week before the test, did you? No. You want a little time to process a little harder things. That's what I thought. Okay. So we have chloride and permanganate. What's permanganate? It's what? No, what is it? What is it? It's a good what? A good what? It's a what? It's an oxidizing agent. So what is it going to undergo?
Reduction.
See, if you knew that right off the bat, like that was in your mind, it's going to help you with the problem right away. All right. So it's in an acid medium. So if we take a look at identify atoms oxidized and reduced, chlorine oxidizes, goes from -1 to 0. Manganese goes from +7 to +2. Oxidizes and Mn reduces. +7 to +2. All right, anybody agree or disagree with that? All right, so what you want to do is write the half reactions, balance mass if necessary using H2O, and add oxygen and or H plus to add hydrogen. See if you can do those two now. And then I'll plop them up there for you. I'm so hoping the gas evaporates off my shoe. Can't stop smelling it. It's wonderful. Ooh, it's raining. Yummy.
On snow.
Melt the snow. Get ready for the golf season. This is the day you gotta use an orange ball. So maybe you need to be adding some water somewhere, I don't know, something like that. Poke your head in there, try to give it a shot. Try to give it a shot. The oxidation one is pretty easy. 2Cl minus to chlorine, Cl2. Right? Don't really have anything else going on there. All right? What about reducing? Might need some waters or something in that, maybe some hydrogens. What do you think? Who thinks they have it? Who thinks they have the reduction portion done? All right, Chris, what do you got?
8 H pluses and then 4 waters.
All right, so 8 H pluses plus MnO4 minus yields Mn2 plus and 4 waters. That's reduction. That is the oxidizing agent. That's cool. All right. Now, balance the charges using electrons. Each electron adds a -1. So, how many electrons are you going to need in the first part of 5, the chloride to chlorine? How many are you going to need there? 2 electrons. 2 electrons. All right, very good. And I did a little math there on the right because now I'm trying to break it down a little bit more. We did on the other one. Now, anybody have the bottom one? DeMarco, I bet you got it now. What do you got? Oh, I mean, come on. Look, it's right here. It's right here. Come on. How many electrons do you need? Electrons. Going with 5? Perfect. Perfect as a slice of pie in heaven. Plus 8 minus 1 minus 5 equals plus 2 plus 0. Very, very good. All right, now we're not done yet. Now we get to continue the problem on. Aren't you excited? We've only done 1, 2, 3, 4, 5. We have a 6. We have a 6 to do. Don't look yet, don't look yet, don't look yet. Okay, there you go. You can look now. All right, multiply the half reactions, half equations, so that the electrons lost in one equals the electrons gained in the other. All right, so see if you can do that. What numbers are you going to be using? What numbers are you going to be using? What numbers are you going to be using? 5 and 2. Gosh, I wish I had you guys on Tuesday, not Wednesday. Five and 2. Why are you using 5 and 2, Michael? I have very bad indigestion. What do you think? One's got 2 electrons, the other one has 5. Okay. We'll see if you can do that. That's what I did. 5 times the whole thing, 2 times the whole thing. Then try to add them up. Cancel out any substances that appear on both sides and see if you can come up with an answer. What?
Like on the six, it's under 2 plus, right?
2 plus is, sorry, that should be up higher. All right, see if you can add them up. Add them up. See if you can get the answer. The answer. The answer, my friends, is blowing in the wind. Class has no energy. No energy. I had to say semen 15 times in bio for them to start laughing. I was talking about the guys on Navy ships. Come on. What were you thinking?
I was
Get
thinking,
your head out of the mud, buddy.
thinking bio class.
Come on now.
I had to say Stephen 5 times to get the.
Golly.
Semen. The semen.
You can
Come
imagine
on, guys.
doing that.
Come on. How many more times are we
I feel like I'd be on the floor and everybody would be like.
Just not feeling it.
All right, I should see an answer. Spency, come on. This easy part. 10 Cl minus yields 5 Cl2 plus 10 electrons, 16 hydrogens. Those two should be the easy part. Distribute out the 2. Distribute out the 5. So 5 times 2 is 10 Cl minus. That should be right on the top, the first line. First line, number 7, should be 10 Cl minus yields 5 Cl2 plus 10 electrons. That's the easy part. You should be able to get those two. This should not be rocket science right now. Getting up to this point may feel like it. Pulling teeth sometimes. Not that bad. You've done it before. A year ago, that's correct. Oh, Chris is feeling it. Put his pencil down.
I got it.
If you think you got it, just drop your pencil. Just go like this. You know, like, just drop your pencil. You get it right, just drop your pencil.
It's already down.
You gotta pick it up again. You gotta just like a basketball
More
player.
effort than I'm really willing to accept. One-seventh of your life has been Wednesday.
Look at that! Dropped his pen. He didn't put the final answer yet.
Well, that's dumb because I know what it's telling me to cancel
But you
out.
gotta have a cancel, bro.
I already canceled out in this step, so.
Yes.
All right, you gotta write the overall.
Inform Michael what that is. He doesn't know. Make sure Michael understands what that is. 'Cause
All right.
he probably never experienced it before.
All right. Here's what I have. 10 Cl minus plus 16H plus 2 MnO4 yields.
I've done
Why did I mess that up? Where am I?
it. See, that line messes everything up. I skipped that line because I knew there was going to be a problem.
Up, yeah. All right, yeah, they're on the electrons. Sorry, that messed it up. Plus yields 5 Cl2 minus plus 2 Mn2 plus and 8 waters. All right. You have one more to do. Try it on your own right now. It's in a basic pH. Basic pH. You can use the steps. I put the steps out there for you again. And all the steps are on the right. I'm going to save this one where it's at. I'll go over the next one very quickly, and then we're going to start on our worksheet that we got last class. That I know all students that were absent saw me yesterday to get.